So today we are in chapter 6, the normal distribution. We'll be working on a lot of examples on normal distribution. Probably it will take a little bit more than 1 hour to complete all the problems. So we are going to begin directly with the examples. So this is our example 1. Let's find out what is asked here. Draw the normal distribution. In your note catcher, probably it says this, draw the normal distribution. I already drew the normal distribution for each case. In your note catcher, there are 6 examples, but I'm going to solve 3 of them. You'll try 3 others by yourself. Okay, and set the appropriate area. Based on this situation, we have to set the area and we have to find the probability for each of these. So for the first one, the question is we have to find the probability that the z-score is less than 2. So you know that along the x-axis, you have your z-scores. And in the middle for the standard normal distribution, because this is the case of standard normal distribution, your mean is 0. Okay, for standard normal distribution, mean is 0 and standard deviation is 1. We have to find the probability that your z-score is less than 2. So if 0 is here, your 2 will be somewhere there. So this is your z equal to 2. We have to find the probability that z is less than 2. Less than 2 means to the left. That is, we have to find this area. Probability that z is less than 2 will be equal to this area here. So you can write like this, probability that z is less than 2 is equal to, and you already know that in order to find the probability or area, we use the normal CDF in our calculator. Normal CDF. And then let me write it a little bit on this next line so that I can fit everything here. So this is equal to normal CDF in your calculator. You put the lower limit for the area. So for this area, it extends all the way to negative infinity. So it is negative E99. Then the upper limit for the area is 2. Mean is 0. Standard deviation is 1. Now if we type that in our calculator, what do we get? Let's find it out. So here in our TI-84 calculator, please follow along with me. We go to second, and then we go to vars, then number 2. So lower limit is negative E99. I already have that here, negative 1 E99 or E99, it's same thing. Upper limit is 2, so we put 2 there. Mean is 0, standard deviation is 1. Paste this in the main screen. It appears like the way we wrote on paper. And then what we do is we hit enter. Enter. And you get the result. You can write up to 4 decimal places. So that will be 0.9772. Okay, when you write up to 4 decimal places. Now part B. In part B, we have to find the probability that z is more than 2.15. So along the x-axis, as I mentioned, you have the z-score. Mean of 0 is in the middle. So your 2.15 will be somewhere here. So suppose that value is 2.15. We have to find the probability that the z-score is more than 2.15. 2.15 is here. More than that is to the right. So you select the area on the right like that. Then we want probability that z is more than 2.15. This is equal to, we use our calculator again, it is normal CDF. Your lower limit is 2.15, right? It's 2.15. We go up to infinity, so E99. E99, please mute yourself.
Well, I'm sorry, I have a question. Mine on the note catcher, ours is actually Z.
It should be Z greater than 2.15. Okay, so the lower limit 2.15, upper limit is infinity, your mean is 0, standard deviation is 1. Now let's again type this in our calculator together. I'm going to share my calculator. In TI-84 calculator, we go to second, then vars, then number 2. Lower limit in our case is 2.15, so 2.15. Upper limit is positive infinity, so it is second and then comma, that will give you E99, which is positive infinity, mean 0, standard deviation 1. Paste that on the main screen, that's what you'll get, and hit enter, and that is your result. And if you write up to 4 decimal places, it should be 0.0158. That is the result. Now part C here. In part C, we have to find the probability that the z-score is between 0 and 1.23. So as you know that along the x-axis, you have your z-score with 0 or mean in the middle, mean of 0 in the middle. Okay, so in the middle is your mean. Hold on. So mean is here, that is your 0. We have to find that the z-score is between 0 and 1.23. So if 0 is here, 1.23 should be somewhere there. So maybe that is 1.23. We have to find the probability that z is between these two values, which is equal to that area. So it will be equal to this shaded area. So when you find probability that your is between z is between 0 and 1.23, we use the normal CDF in our calculator, which says normal CDF. The lower value for the area is 0, upper value is 1.23, mean is 0, standard deviation is 1. Now, we are going to type this in our calculator. So in our calculator, we go to second and then vars, then number 2, lower limit, it is 0, upper limit for the area or the upper boundary is 1.23, mean is 0, standard deviation 1. Paste that in the main screen. This is what we have written on our paper. Then hit enter to get the result. And if you write up to 4 decimal places, it should be 0.3907. So always remember, when you're calculating the probability, it will be equal to the area under the curve between the given values. And to find that area in your calculator, we use normal CDF. Okay, to find the area, we use normal CDF. And first we write the lower limit, then we write the upper limit, then we have the mean and the standard deviation. This is like the formula that you need to remember. This is what we enter in our calculator to find the area or the probability. Example 2, we have to find the z value that corresponds to the given area. Here the area is given, you can see. We have to find the z-score. For example, here is the z-score. Okay, what is that z? We have to find it. They have given that area. Here is the z, they have given that area. We have to find what is that z. Here is the z and there is the area. So in order to find the z-score, the score along the x-axis, it can be a z-score for standard normal distribution. Otherwise, it will be the x value, the continuous normal variable, if it is just a normal distribution. In order to find that, in order to find the x value or z value in your calculator, let me show you. Give me a second here. So here, the formula that you need to remember for your calculator is, in order to find x or z-score is equal to, we use inverse normal in our calculator. We put the area, we put the Okay. So to find the x or z score, it's equal to inverse normal. Here is the area to the left of z, to the left of z or x, whatever is there in the x-axis, z or x. That's your first thing. You have to put the area, and then you'll write your mean, and you'll write the standard deviation. This is like a formula, so please write that down. So let's try to understand the meaning of that and how we can use calculator like this. For example, in the first example here, in the first part, they have given this area, which is 0.4817. That is the area given here. We need to find this z value. So in order to find that, we must know the total area to the left of that. When I say total area to the left of that, I know only this area. Everybody look at that figure. I have the area from here to here. I don't have this area. I don't have the area from here, from the middle, all the way up to the entire left or to negative infinity. Do you know how much area will be here on the left of mean? Because the total area is 1, this is half of that. So this area is 0.5. So the total area to the left of z score will be 0.5 plus that. So first we are going to find that area to the left. You can write this area to the left of z. Left of z is equal to 0.5 plus 0.4817, which is equal to 0.9817. So this area in red color, is that a red color? Plus this area here, that is equal to 0.9817. So I added this area. This area is half of 1, which is 0.5. So I have the entire area to the left of z, because I need the area to the left of z in order to find that z score. That's why we need the total area on the left of that. So after we have this, we use this command here. We need the z value. So z is equal to inverse normal. Make sure you write this down. The area, we got 0.9817. 0.9817. Mean is 0.9817. Mean is 0. Standard deviation is 1. Now we need to type this in our calculator. So I'm going to share my calculator here. So in this calculator, what we do is, you can follow along with me. We go to second, and then vars, then go to number 3, because number 3 has inverse normal. Number 3. Now here you'll type the area to the left of z score, which is, in our case, it is 0.9817. Then the mean is 0, standard deviation is 1. After you paste that in the main screen, this is just like our writing. Then hit enter. You will get the value of z. Z is equal to, in this case, we get 2.0902. That's your z score. So here we got z equal to 2.09202902. 902. That makes sense because this is 0. So this must be greater than 0. So maybe somewhere here is 1. So this is a little bit more than 2. So it is 2.0902. Okay, second problem here. You can see they have given the area. Here is the z. They have given the area to the right of z. Area to the right of z is 0.0427. That is given. But we want the area to the left. Actually, we want this area. We want the area on the left. You know that the total area is 1. So from 1, you have to subtract this area to get this one, to get the area on the left. So let's first write that. Area to the left of of your z-score is equal to 1 minus 0.0427. And when you subtract that, do it in your calculator, you should get 0.9573. So that is the area to the left of that z-score. Once you get the area to the left of the z-score, we use this comment here. So z equal to inverse normal. We put the area on the left, which is 0.9573. Mean is 0. Standard deviation is 1. Now we are going to type that in TI-84 calculator. Okay, in TI-84 calculator, we go to second, then vars, number 3. We put the area, which is 0.9573. Mean is 0. Standard deviation is 1. Paste that so that it looks like our writing, and then hit enter. And you got the result. And the result is 1.7202. 720, if you round it to 4 decimal places, 2. So we got the z-score, it is 1.7202, and that makes sense because the z is to the right of 0. So somewhere here that should be 1. So that must be 1.7, which makes sense. Okay, this is the third one. Here you can see we want to find this z-score. They have given the area to the right. We need the area on the left. We actually need this area in order to find the z-score. So let's find that area. It will be total of 1 minus that area. So area, you can write this, area to the left of z is equal to 1 minus 0.7224, this area, 1 minus 0.7224. And if we subtract this using our calculator, you should get 0.2776. So that is the area we need because we need the area to the left of z-score. So let's write down the standard comment in our calculator. Z equal to inverse normal. Area to the left is 0.2776. Mean is 0. Standard deviation is 1. Now we are going to type this in calculator. And if you look at the figure, you can see here is our 0, the mean, and the z-score is on the left. So the numbers on the left are smaller than 0. Meaning of that is this z-score must be negative. Let's see whether we get negative or not by using the calculator. In TI-84 calculator, we go to second, then vars, then number 3. So here we put the area that we have just calculated, which is 0.27762776. Mean is 0. Standard deviation is 1. Paste this in the main screen so that it is similar to our writing. Then hit enter. See, we got the negative value. So it is negative 0.59. 0.59. If you try to round it to 4 decimal places, it will be 0. Then again, we get 0 here. So it will end up with 5.900. That is the result, or that is the z-score in the third part. Okay, we'll go to example 3 now. Here is the example. First, we are going to read. We are going to sketch it properly, label it, then we'll answer it. Find the z-value to the right of mean such that 96.49% lies to the left of it. So let's draw the normal distribution with z-score along the x-axis. Okay, z-score along the x-axis. We are calculating the z-value. So as we are calculating the z-value, you can consider this as the standard normal distribution with a mean of 0 and standard deviation 1. So your mean is here in the middle, which is 0. Okay, as we are calculating the z value, we consider that the mean is 0 and standard deviation is equal to 1. Okay, what we are asked to do is we have to find the z value to the right of mean. To the right of mean, that means we are looking for a positive value, okay, to the right of the mean. So maybe somewhere here is that z value, and we need to find what is that z equal to. So what is this z equal to? We need to find out the value of z such that, okay, such that 96.49% of the area lies to the left of it. To the left of this one, or the area to the left of that z score, when I say area to the left of the z score, we are talking about this area. This is the area to the left of that z score. Okay, and this area is 96.49%, or it is 0.9649. That is the area. So if that is the area, we have to find the z score. And you know that in order to find the z score, we always need the area to the left. They have already given the area to the left. So this is easy. So here, area to the left, let's write that down here. Area to the left of z is equal to 0.9649. So to find the z score, you'll use the inverse normal in your calculator. Inverse normal. Area to the left is 0.9649. Mean is 0. Standard deviation is 1. So if we type this, we should get the z score. Okay, we are going to type this in our TI-84 calculator. Let me show you that. So in TI-84 calculator, we go to second, then vars, then number 3. And here we type the area to the left, which is 0.9649. 9649. Mean is 0, standard deviation is 1. Paste this on the main screen so it looks like our writing. Then hit enter and we get the value, which is 1.8106 if you round it to 4 decimal places. So that is your z score. Okay, we'll go to example 4. Here is that. Find the z value that is to the left of mean such that 99.01% lies to the right of it. Okay, so here we want to find the z score. You know that the z scores are along the x-axis. In this case, because we are calculating the z value, mean is 0, standard deviation is 1. So your 0 is here in the middle. That is your mean. The question is, we have to find the z value that is to the left of the mean. To the left of the mean, we want the z score. So we want this z value. What is this z equal to? We need to find out how much is this z such that 99.01% of the area lies to the right. To the right of this z, we have 99.01% area. So meaning of that is this area, which is to the right of that z score, the total area, you can say it like this. So this area is 99.01%. So this is 99.01%, or which is same as 0.9901. But what we already know is in order to find the z score, we need the area on the left. So from the 1, we have to subtract and get this area. So that's our first thing. Area to the left of z is equal to 1 minus 0.9901, which is equal to 0.0099. Subtract that in your calculator. 1 minus 0.9901, it should be 0.0099. That is the value of your area. So once you have this area, we can use the command in our calculator, which is Z equal to inverse normal. Okay, inverse normal. Area is 0.0099. Then your mean is 0. Standard deviation is 1. So we are going to type that in our calculator. Okay, in TI-84 calculator, we go to second, then vars, and then number 3. And here we type the area, which is 0.0099. Mean is 0, standard deviation is 1. Paste that in the main screen, we got that. And then hit enter. We got a negative value because it was to the left. And we got negative, let's write it down, negative 2.3301. If you round it to 4 decimal places, 3301. So we got our z-score negative 2.3301 because it is to the left of 0. So the value will be negative. So it is negative 2.3301. Okay, we'll go to next example, example 5. Let's find out what is here in this example. We have to find the two z values. One is negative and other is positive. So here we are looking for two z-scores, one positive, one negative, so that the total area of the two tells is 1%. Assume that we want equal area in each tell. So when I say tell, this area on the left end and area on the right end, that is the tail area. So if this is the x-axis where we have the z-scores, what they want is here in the tail, they want the total area so that the total area of the two tail is 1%. So area here and area here, when you add two areas, then it is equal to, if you add these two areas, it is equal to 1%. But now the 1% is divided equally into two parts. Assume that we want equal area in each tail. So if you divide 1% into two parts, you have the 5% area here and 5% area here. So when I say 5% area, that is 0.005, that is 5%. This is 0.005. That's your 5% area. So we want the two z values. So here the z will be positive, some value, and here this will be negative z value. What we know is, if I know this value, it will be the same value here with opposite sign. For example, if this is 2.3, then this will be negative 2.3. So all I need was area on the left of the z-score. I already have that area. Area on the left of negative z is this one. Let me write that. Area on the left of negative z is equal to, you have 0.005. Now, in order to find this z-score, we use the prompt in our calculator, which was z equal to inverse normal. Your area is 0.005. Mean is 0. Standard deviation is 1. We know that we are going to get this value negative because we are talking about this area and this z value. So let's type this in our calculator. So in TI-84 calculator, you go to second and then vars, the number 3, where it says inverse normal. So you put the area here, which is 0.005. 0.005. Your mean is 0. Standard deviation is 1. Then paste it. This is just like the way we have written on our paper. And when we hit enter, we are expecting a negative value. So if you enter, see, we got the negative value, which is negative 2.5758. So here we got negative 2.5758. That is the value of the z-score, which is here. We want the two z values, so this will be positive. So you can write the required z values are, the required z values are, one is positive, one is negative, because these values will be equal but opposite in sign. So if this is negative, this one will be positive. So plus or minus 2.5758. That is the value of z, and these are the two different values. Okay, problem number 6 here. Let's see what is given and what we are asked to find. We have to find the two z values, just like in the previous one negative and other positive, so that the middle 70% is bounded by two values. So not the side values, not the area on the tail, but area in the middle is 70%. So if we have this x-axis here, where we have the z scores, we need these two z values. This is negative value, and this should be the positive value, so that the area in the middle, this area in the middle is the 70% area. This area is 70% area, or 0.70. We need to find these z values. In order to find the z value, you know that we need the area on the left. We need this area. So if I want that area, you can see if I want this area here, this area and the area over here, they are equal, but I need this area. How much is that? Area on the left of this z value. The total area is 1. From 1, if we subtract, let me write here, area to the left of negative z is equal to, okay, from 1, if I subtract 0.7, see, from 1, if I subtract 0.7, the area in the middle, then I get 0.3. Then I get 0.3. This 0.3 is the total area on the left tail, and the right tail. But these are equally divided because of the symmetric nature of the bell curve. So what we have to do is, we have to divide this difference by 2. So if I divide this difference by 2, then I get 0.15. So this area on the left is 0.15. Okay, this is 0.15 or 15%. So if this is 15%, this is also 15%. So 15 plus 15 is 30. 30 plus middle 70 is 100. We are interested in the area to the left of this score, z score here. And we got that, that is 0.15. Now in order to find this negative z value, we use this prompt in calculator, inverse normal. Okay, area is 0.15, mean is 0, standard deviation is 1. Make sure you write that down. Then we are going to work on the calculator. In TI-84 calculator, we go to second, then vars, then number 3, area is 0.15, mean is 0, standard deviation is 1, paste it. This is just like the way we have written. Then enter and expect the negative value. See, we got the negative value. So we get negative 1.0364. So we got the negative z value, that is this score here, and this one will be equal, and it will be positive. It will be 1.0364. So the two z values are, you can write this down, two z values are, one is positive, one is negative, 1.0364. Now next example, number 7, it has several parts. We are going to solve each of these. So let's first read the problem. At a community college with only commuter students, a study determined that the mean travel time for the student in the morning from their homes to the campus is 25 minutes. So that is the average time they need to go to college from their home, with a standard deviation of 4.5 minutes. So that is the information given to you. What we are assuming here is Assume that the travel time is normally distributed. So along the x-axis, you have the travel time, which is normally distributed. We have to answer each of the questions. The first part is, find the probability that randomly selected students take less than 20 minutes to get to the campus in the morning. So what we know, let's first complete the drawing here. Along the x-axis, you have the time, which is denoted by x. Okay, in the middle, right in the middle of the graph, you have the mean, and the mean is given to be 25. That is given to you, that is 25, that's the mean. Now, we need to find the probability that randomly selected student take less than 20 minutes. 20 is here, 25 is here, so 20 should be somewhere there. So suppose this value is 20. Okay, suppose that is 20. We have to find the probability that randomly selected student take less than 20 minutes. When I say less than, it is this one. We have to find the probability that it takes less than 20 minutes. So the probability will be equal to this area. And we know that in order to find the area, probability that x is less than 20 minutes, or the time is less than 20 minutes, is equal to, you do normal CDF in your calculator. Then the lower limit for this area is negative infinity, so negative E99. Upper value is 20 for the area. Mean is 25, and the standard deviation is 4.5. So this is what we need to type in our calculator. Let's do that. So in TI-84 calculator, you go to second, and then second and then VARs. And we want the normal CDF, which is number 2. The lower limit is negative E99, which is already there in my calculator. Upper value is 20. We have the mean of 25. And the standard deviation 4.5. So we type all this and paste this in the main screen so that it is like our writing. Then hit enter, and we got the result. So the probability is 0.1333. So the probability that it takes less than 20 minutes to arrive at the campus is 0.1333. So we got the probability 0.1333. We'll go to 7B. Here is that problem. Everything is same. The mean is 25 minutes. Standard deviation is 4.5. But let's see what is asked here. Always remember, you have that mean of 20 in the middle. No, mean of 25, not 20. 25 in the middle. 25 is there in the middle. We have to find the probability that a randomly selected student takes more than 35 minutes to get to the campus. More than 35 minutes. 25 is here, so 35 will be somewhere there. So suppose that is 35. We want to find the probability that it takes more than 35. So for more than 35, this is the area. So we want probability that x is more than 35. So in order to find this area, which is shown here, we use normal CDF in our calculator. Normal CDF. The lower limit for the area is 35. Upper limit for the area should be E99. Mean should be 25. That's what we have. Standard deviation is 4.5. So we are going to type this in our calculator. So in TI-84 calculator, we go to second and then distribution. And number 2, which is normal CDF. The lower limit in our case, we have 35. Upper limit is infinity or E99. If you press second and comma, you get E, then 99. Mean of 25, standard deviation 4.5. You paste it, you'll see your writing, then hit enter. So that is your result, which is 0.0131. So the result is 0.0131. That is the probability that it takes more than 35 minutes for the students to arrive at the campus. So here is C, the third one. We have to find the probability that a randomly selected student takes more than 15 minutes to get to the campus in the morning. So your mean, which is 25 minutes, is here in the middle. That's your 25 minutes. We have to find the probability that a randomly selected student takes more than 15 minutes. So 15 should be less than 25, which is here. So that should be 15. And we want the probability that it takes more than 15. More than 15, the probability that it takes more than 15 minutes will be equal to this area. So here we write probability that X is more than 15 is equal to, again, because we are calculating the probability or the area, we use normal CDF. Normal CDF. The lower limit is 15 in our case. Upper limit, we go up to infinity, so E99. Mean is 25. Standard deviation is 4.5. So we are going to type that in our TI-84 calculator. In TI-84 calculator, we go to second, then vars, and number 2, which is normal cumulative distribution function. So number 2, the lower limit is 15. Upper limit is infinity, mean is 25, standard deviation is 4.5. When you paste it in the main screen, it looks like our writing. Then hit enter to get the result, which is 0.9869 if you write it up to 4 decimal places. So that is the probability. Probability that it takes more than 15 minutes is 0.9869. Now part D of the same question, we still have to find the probability that randomly selected students take between 10 to 40 minutes to get to the campus in the morning. So you know that your mean is here in the middle, which is 25 minutes. We want to find the probability that it takes time between 10 through 40 minutes. 10 minutes should be somewhere here. This is your 10 minutes. 40 minutes should be somewhere here. We want to find the probability that it takes between 10 to 40. So between 10 through 40 is this time, which is equal to area under the curve bounded by x equal to 10 and 40. So we have to find that area. That is the probability. So probability that the time is between 10 and 40 is equal to your normal CDF, because we are calculating the area. So normal CDF, your lower limit is 10, upper limit is 40, mean is 25, standard deviation is 4.5. So we need to type that in the calculator. Let's do that. So in TI-84 calculator, we go to second, vars, and then number 2 for normal CDF. Your lower limit 10 in this case, upper limit is 40 in this case, mean 25, standard deviation 4.5, paste that so it resembles our writing, and hit enter, and you should get that result, which is 0.9991. 0.9991. Meaning of that is 99.91% of the students, they take 10 through 40 minutes to arrive at the campus in the morning. Okay, that is D. Now we go to E. Here is our E. Same problem, but let's see what is asked here. We have to find you can see here, we have to find the cutoff score for top 25%. They said the students that have longest 25% of the travel time arrive rush to their class, which is true if they take the longer time, okay, and they start at the same time, they have to rush a little bit. So we have to find that cutoff score for the top 25%. So along the x-axis, you know that you have your z-score or the time value. Here it is x. Top 25%, when I say top 25%, this is your top 25%. Okay, this area is 25% or 0.25. That is your top 25%. For this top 25%, what is the time? What is this x value? We need to find what is this x equal to. So in order to find the x or the z-score, you know that you need the area on the left. So we have to find the area on the left in this case. So let's find that. Area to the left of x is equal to 1 minus 0.25, which is equal to 0.75. So 75% of the area is on the left. Now what we know is in our calculator to find that x, we can use x equal to inverse normal, area to the left 0.75, mean is 25, standard deviation is 4.5. So if we do this, we'll get the cutoff score for top 25% of the student, or who takes top 25% of the time to arrive the campus in the morning. So in TI-84 calculator, you go to second, then vars, because we are using the inverse normal. This is number 3. Area on the left, we just got 0.75. 0.75. Mean is 25. Standard deviation is 4.5. Then you paste this to the main screen. It resembles our writing. Then hit enter. We get this value. Let's copy this. In calculator, we got 28 point, okay, 28.0352, or you can say approximately 28 minutes. That is the cutoff score for the top 25% of the students who take more than 25% of the total time to arrive at the campus, is approximately 28 minutes. That is the cutoff score. And the last one is here. Same question. You have the mean and the standard deviation. Now what we have to do here is we have to find the student that arrived the shortest 20% of the travel time get to find better sitting in the class by arriving earlier. That's very true. If you arrive early to the class, you get a better sitting place. So we have to find the cutoff for the bottom 20% of the student. So cutoff time for bottom 20% of the student. You know that along the x-axis, you have the time, which is denoted by x. Your mean is here in the middle, which is 25. That's your mean. We need the cutoff score for the bottom 20% of the students. So this is 20% area or 0.20. So what is this x? We need to find that. So you already have area to the left of x. It is 0.20. So let me write that. Area to the left of x is 0.20. It's already there. Now, in order to find your x value, we use inverse normal in our calculator. Area to the left 0.20, mean is 25, standard deviation is 4.5. So we need to type this information in our calculator to get the x value, the cutoff score for bottom 20% of the students. We go to second, vars, number 3 for inverse normal. Our area on the left is 0.20. Mean is 25, standard deviation 4.5. When you paste it, it is just like the way we have written on the paper. Hit enter, you get the result 21.2127. So we got 21.2127. You can say this is approximately 21 minutes. For the first 20 minutes who are arriving early, or for the 20% of the time they arrive early, that is 21 minutes.